Lecture 2 of 3. Subtopic 7.2 Combination. Learning outcomes. At the end of the lesson, students should be able to A. Find the combination of a set of objects. B. Determine the number of ways to form combinations of R objects from N objects. Definition. A combination is a selection of one or more of a set of objects with no considerations given to the order or arrangement of the objects. There is a difference between a permutation and a combination. In a permutation, the order or arrangement of the objects is important, whereas in the combination, the order is not important. For example, from the three pictures A, B, C, if we arrange two pictures, the permutations are AB, AC, BC, BA, CA, and CB. Here, AB is not equal to BA. BC also does not equal to CB. CA also not equals to AC. Therefore, the total number of permutations is 6. However, in combination, the order is not important because AB equals BA, BC equals CB, and AC equals CA. Hence, AB and BA is considered as one combination and so on. Therefore, the total number of combinations is only 3. Example 1. Determine whether each of the following is a permutation or combination. 5 pictures placed in a row. Okay, it should be permutation because we arranged 5 pictures in a row. 3 storybooks picked from the rack. This must be combination. A team of 9 players chosen from a group of 20. This is also combination. We just go to choose. Okay? We are now arranged 9 players. The arrangement of the letters in the word October. Okay, must be permutation because we have this word also arrangement. Types of food in a plate taken for lunch consist of rice, vegetables, chicken curry, and prawn paste sambal. This must be combination because we don't arrange rice, vegetables, chicken curry, and prawn paste sambal in a plate. Therefore, we can conclude that permutations are used when order is important and combinations are used when order is not important. Combination of R objects from N different objects. The number of combinations of N different objects taken R at a time is NCR. Where we have the NCR equals N factorial over R factorial times N minus R factorial. Or this is the definition of NCR. Example 2. There are 6 bottles of liquid dyes consisting of the colors red, green, blue, yellow, white, and black. Calculate the number of selections of the mixture of 2 different colors from the available 6 colors. So, number of ways to select the mixture of 2 colors is 6C2. Okay? Equals 6 factorial over 6 minus 2 factorial times 2 factorial, or just press your calculator. Okay, your calculator button of NCR to 62. Okay, we will get 15. Example 3. A quiz team of 4 is chosen from a group of 15 students In how many ways could the team be chosen? Solution. Okay, so we have from 5 students, we want to choose only 4, so 15 C4, 1,365 ways. Okay, so the team, okay, can be chosen in 1,365 ways. Example 4. A bicycle shop owner has 12 types of mountain bikes in a showroom. The owner wishes to select 5 of them to display at a bike or bicycle show. How many different ways can a group of 5 are selected? Okay, so just 12. Okay, from the 12 types of mountain bikes, we choose 5. Okay, so we have 12 factorial over 7 factorial times 5 factorial, so we have 792 ways. Example 5. In a test, a candidate is required to answer 8 out of 10 questions. Find the number of ways a candidate can answer the questions. B. Can answer the questions if the first 3 questions must be answered. Solution. The number of ways of answering 8 out of 10, okay, question is 10 C8 equals 45 ways. And then B, we have a condition to be fulfilled, that is if the first 3 questions must be answered. So the number of ways of answering if the first 3 questions must be answered, and there are now left to choose 5 questions out of 7. Because originally we have 10. Okay, the first 3 must be answered, and we can choose only 5 out of 7 or from 7 questions. Thus, the number of ways is out of 10 questions is 3 C3, stand for the first 3 questions. Okay, times, this is the 5 questions out of 7 questions. Okay, good. We have 21. Combinations with conditions. Some problems on combinations involve choosing objects under certain conditions or restrictions. The given conditions must be taken into account when using the NCR formula together with the multiplication principle. Okay, example 1. If there are 8 girls and 7 boys in a class, in how many ways could a group be chosen so that there are 2 boys and 2 girls in the group? So we have, okay, we have 8 girls and we want to choose 2 girls. So 8C, 2N. Okay, so times 7 boys and we want to choose 2 boys. Okay, so we have 588 ways. Example 2. There are 6 points on the circumference and 4 points on the diameter of a circle. Calculate the number of triangles which can be formed by joining any 3 points as their vertices. Okay, so we have a circle, we have the points, okay, 6 points on the circumference and 4 points on the diameter. If you go to join any 3 points, so you can see that it will form, okay, a triangle. Okay, as this point will be the vertices of the triangle. So altogether, we will have 10 points, and the 3 points are joined to form a triangle. So we have 10C3. But a triangle cannot be formed by joining any 3 out of the 4 points that lie on the diameter, which is a straight line. Okay, so we have 4C3. This 4C3 cannot form a triangle, which is already included into 10C3 just now. Hence, the number of triangles which can be formed is 10C3 minus 4C3 equals 116 ways. Okay, example 3. A 3 committee is to be formed from 4 couples. Find the possible number of committees that can be formed if all the members are men. Okay. B. The husband and the wife cannot be in the committee at the same time. So the number of combinations where we have all the members are men. Okay. We have 4 couples. Okay, so that means 4 men. Okay, we have 4 men, and we need to have 3 committee, 3 person in a committee. So we have 4 stand for the men. Okay, and we want to choose 3 out of the 4 men. So we have 4 ways. The number of selecting 3 groups from 4 groups equals 4C3. Okay, because in this section, the husband and the wife cannot be in the committee at the same time. So now we have to select first group, okay, from these 4 groups. So we have 4 group 1, 2, 3, 4. 4 groups of 4 couples. Okay. We have to select 3 groups from the 4 groups, so 4C3 first. And the number of choosing 1 person from each of the group selected is 2C1 times 2C1 times 2C1 equals 8. 2C1 is we will choose 1 person from a group. For instance, with the first group, okay, we choose 1. Okay, the other one will remain. Okay, and then this one also we will choose 1 person from the second group, and this is 1 person from the third group. Okay, so we will have 8 ways. Thus, the number of combination is 4C3. Okay, select 3 group from 4 groups. Okay, then times from the group already chosen just now, we select 1 person. Okay, another group we will select 1 person, and another group we will select 1 person. So the number of combinations so that the husband and the wife cannot be in the committee at the same time is 32 ways. Example 4. A school committee consists of 6 girls and 4 boys. A social subcommittee consisting of 4 students is to be formed. In how many ways could the group be chosen if there are to be more girls than boys in the group? Solution. If there are to be more girls than boys in the group, then the group will either have 4 girls and no boys, or 3 girls and 1 boy. 4 girls can be chosen in 6C4 because girls we have 6, so we want to choose 4. Okay, 15 ways. 3 girls, okay, and 1 boy is chosen 6C3 times 4C1. 6, okay, this is the 3 girls from the 6th person, and this is 1 boy from the 4 boy. Okay, so we have 20 times 4 equals 80 ways. This one, 4 girls can be chosen in 6C4, okay, and 4 girls and no boys. Okay, so we don't have to choose any boy from these 4 boys. So that's why only we have 6C4. And therefore, the number of ways of choosing the group, if there are more girls than boys, is 15 plus 80 is 95 ways. Example 5. From a group of chess players, which consists of 4 male students and 3 female students. A school team, which consists of 3 students, is to be formed. Calculate the number of ways the team can be formed if it must consist of exactly 2 males. B. The number of females must be more than the number of males. Okay, now we go to A. Number of ways the team can be formed if it must consist of exactly 2 males, which means that the third selected student is a girl. Okay, so we will have 4C2. 4 is male students. We have to select exactly 2 male students. So 4C2. And the other one is we have to select 1 female student. Originally, we have 3 female students. So 3C1 equals 18. B. The number of female must be more than the number of males. So we can construct this table. We have male students, 5 female students, we have 3. If you want to have female must be more than males, okay, female equals 3 and no male students, because we need to have 3 students in the team, or 2 female and 1 male students, because females must be more than males. So the number of ways is 4C0, okay, 4C0 times 3C3, okay, or, so plus here, okay, 4C1 times 3C2, okay, so 1 plus 12, we have 13. Example 6. In a football training squad of 24 people, 3 are goalkeepers, 7 are defenders, 6 are midfielders, and 8 are forwards. A final squad of 16 selected for a match must consist of 2 goalkeepers, 4 defenders, 5 midfielders, and 5 forwards. Find the number of possible selections is 1 particular goalkeeper, 2 particular defenders, and 3 particular midfielders, and 3 particular forwards are automatically selected. Okay, so we have here goalkeeper 3. Okay, goalkeeper, we have 3 goalkeeper. Defender, we have 7. Midfielder, we have 6, and forward, we have 8. And from the goalkeeper, the particular one, okay, have got to be selected. And defender, we have 2, and midfielder, we have 3, we have to select. And from this 8 forward, we have to select 3 particular forward. So number of ways selecting the goalkeepers. So we have 1C1. 1C1, okay, we have to select goalkeepers. Okay, we have to select 3 from this 3 person. Okay, this is particular goalkeeper, so we have to choose this one. Okay, 1C1 times 2C1. Okay, the goalkeeper, we have 3. Okay, and now now we have 2. Okay, 2 person, because the particular one is already selected. 2C1 equals 2. Okay, the number of ways of selecting the defenders. Okay, this is the particular one. Okay, we have 2 particular defender, so this 2C2 have got to be chosen. Okay, we need to have 7. Okay, 7 defenders. Okay, the left behind one is 5, and we want to choose 2. Okay, 2, because just now 2 is already chosen. Okay, from the 5, originally we have 7. 2 is already taken, so we left 5 defenders. and we have to select 4 defenders, so we have to select 2 from this 5. So we have 10 ways. Number of ways of selecting midfielder. Okay, midfielder, we have 6. Okay, 6 person. Okay, these 3 person are the particular one, so we have to select 3 C3. And originally we have 6, and midfielder we have to select 5. So 3 we have to choose 2. Okay, another 2 midfielder, because 3 just now is already chosen. So we have 3 ways. Number of ways of selecting the forward. Forward we have 8. Okay, we need to select 5 forward, and the 3 particular forward have got to be chosen. So you have 3 C3. Okay, and then times, okay, this is the particular one. We have to choose with 3 C3. And midfielders, we have, forward, we have 8. Okay, so the left behind one is 5, and we need to select 2 more to become 5 forwards, which are to be selected. So we have 10. So number of ways of selecting the squad by using the principle of multiplication. So we have 2 times 10 times 3 times 10. So we have 600 ways. Example 7. ABCDEFG is a regular octagon. How many triangles can be formed with the vertices of the octagon as vertices? How many diagonals can be drawn by joining the vertices? Okay, this is the regular octagon. Now we want to form a triangle. Okay, so how many triangles can be formed with the vertices of the octagon as the vertices of the triangle? Okay. Okay. For example, if we join this, okay, if we have this, if we go to join a triangle, the vertices of the octagon like this, we have one triangle. Okay, so a triangle is formed by taking 3 of the vertices. Okay, so you have here 1 vertex, 2 vertices, 3 vertices of the octagon shall be the vertices of the triangle. Okay, so altogether we will have 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8 of the octagon. Okay, so we have to select 3 in order to form a triangle. We have 56. A line can be formed, okay, by taking any 2 points from the 8 vertices of the octagon. Okay, because now we want to find number of lines. Okay, how many diagonals or lines, okay, can be drawn by joining the vertices. So a line can be formed by taking any 2 points from the 8 vertices, okay, of the octagon. Number of lines. So we have, for instance, we have, this is 1 line, okay, or 1 diagonal. Okay, to form, if you go to join the vertices, 1 diagonal line. Okay, this will be 2. Okay, so a line can be formed by taking any 2 points from the 8 vertices of the octagon. We go to take, okay, 1 vertex and this another vertex. We join together, we have a line. Okay, also we will join together, we have got a line. Any 2 vertices, if we join together, we got a line. Okay, so any 2. Okay, 2 points from the 8 vertices, we will have a line. So number of line is 8C2. But then if this 28, okay, 8C2 is 28, include the 8 sides of the octagon. Okay, now if you go to form 8C2, meaning that it also included this vertex and this vertex. If you go to join together, we also have a line, but this is not diagonal. Okay, it's not inside this octagon. So we have to subtract or minus, okay, because it include the 8 sides of the octagon. Okay, so thus the number of diagonals is 28 minus 8 equals 20 only. Because, again, okay, this is 28 including the line, which is exactly on the octagon, the circumference of the octagon. So this will be 8 sides of the octagon, because one side here, it is also fulfilled joining two vertices, okay, and it also form a line, but this is not a diagonal line because it is exactly on the circumference of the octagon. So we have to minus this back. That's why we have 28 minus 8 equals 20 ways. Example 8. 15 students are divided into 3 groups. The group A having 7 students, Group B having 5 students, and Group C having 3 students. Find the number of ways to form the 3 groups. Okay, B, the 3 groups with 4 given students must be in the Group A. So, this is the given student, the particular one. Okay, the particular students must be in the Group A. Okay, number of combination. We have, okay, we need to have 15, we have 15 students are divided into 3 groups. So 15, okay, we have 7 students from Group A. Okay, this from Group A times, we have 7 is already taken, then we have 15. We have 8, and C 5, because B having 5 students, and the balance one is 2 plus 5 is 12. Okay, altogether is 15 students. So we have 3 more. Okay, 3C3. Okay, Group C we have 3 students. So you multiply these values. Okay, then we have 360 ways. Okay, B, the 3 groups with 2 given students must be in the Group A. Okay, Group A is 7 students. Okay, having 7 students. So these 2 students, or the particular one, is from these 7 students. So we have 2C2. 2C2 is the given student, or the particular students must be in Group A. So we have 2C2 times, okay, we will have just now 2 is already taken. Originally we have 15 students, so the balance one is 13, and we have to choose 5 from Group A, okay, because we need to choose 7 students from Group A. Okay, this is already taken 2, so we only have 5 here. And times, this is 7, we have 8, the balance. 15 minus 7, we got 8, and we have to choose 5, Group B. Okay, 8C3, and then times, okay, we have 7 plus 5, 12, so another 3, and we have to choose 3 for Group C. So altogether we have 72,072 ways.